Since time immemorial, mankind has asked itself a question that sparks both awe and fascination: what lies beyond what we know? What exists beyond the limits of our universe? The answer is deeply complex, but recent findings are pushing us closer to the edge of that mystery. The James Webb Space Telescope has spotted something enormous and fascinating in the farthest reaches of the cosmos, something that could potentially revolutionize physics as we know it. So, what exactly has the James Webb found at the edge of the universe? Why are scientists around the world so captivated by this discovery? Join us as we explore how this next-generation telescope has uncovered something gigantic at the very limits of what humanity can observe. Before we dive deeper, don't forget to subscribe to our channel, give this video a thumbs up, and hit the notification bell so you stay up to date with the latest news from the universe and beyond. Albert Einstein reshaped the way we see the cosmos when he developed his general theory of relativity. In 1916, he applied it to the entire universe, showing that the cosmos could not remain static, it must either expand or contract. Then in 1929, astronomer Edwin Hubble confirmed Einstein's theory when he observed galaxies drifting away from each other, proving that the universe is indeed expanding as a result of the Big Bang. This expanding universe creates a limit, the so-called observable universe, a cosmic horizon beyond which light hasn't yet had enough time to reach us. Picture it like standing on the shore, looking at the horizon of the ocean. The universe's version of this is a sphere surrounding Earth, where galaxies are visible out to a distance of approximately 13.8 billion light-years. However, because of the expansion of space itself, the observable universe actually stretches out to around 92 billion light-years across. But what lies beyond this cosmic horizon? Could there be infinite galaxies that remain hidden simply because their light hasn't reached us yet? This is where the James Webb Space Telescope comes in. Being 100 times more powerful than its predecessor, the Hubble Space Telescope, Webb is capable of detecting the faintest infrared light from the earliest galaxies, as well as identifying stars, exoplanets, and other cosmic phenomena far beyond what we've previously observed. Still, when scientists point Webb towards the edge of the universe, there's no telling what exactly it might detect. The cosmos is divided into two parts, the observable and the unobservable. The observable universe contains everything we can currently see, including the faint afterglow of the cosmic microwave background, radiation dating back to around 13.8 billion years ago when the universe was still shrouded in a dense, foggy plasma. Yet, experts suspect that gravitational waves and elusive particles like neutrinos could be coming from even more distant regions, unreachable by today's technology. To truly understand the full scope of reality, cosmologists argue that we must accept that what we see is only a small fragment of a much larger universe. One galaxy that has helped push the limits of our observable universe is known as Abell 2744y1. This distant galaxy is located at the very edge of what we can detect, taking nearly 13 billion years for its light to reach us. Scientists are essentially observing it as it appeared just 650 million years after the Big Bang, essentially looking back in time. The Spitzer, Hubble, and James Webb Space Telescopes have worked together to study such distant objects, using different parts of the electromagnetic spectrum to capture a more complete picture of the early universe. By combining data from these telescopes, astronomers can now examine galaxies up to 100 times farther away than ever before. Using gravitational lensing, where a massive foreground galaxy acts like a magnifying glass, scientists from Canada's Astrophysics Institute and the University of La Laguna were able to calculate the distance and star content of Abell 2744y1. Despite being much smaller than our Milky Way, spanning about 2,300 light-years, it has a star formation rate 10 times higher than our galaxy. But this is just the beginning of what Webb and other observatories are uncovering at the limits of the universe. Before the discovery of Abell 2744 Y1, the most distant known galaxy had a redshift value of over 7. Redshift is how scientists measure how far light has been stretched as the universe expands. Abell 2744 Y1 has a redshift of 8, meaning its light has shifted even further into the red, or infrared, spectrum. However, astronomers have now discovered something even farther away, a supernova named Day 16C2NM, spotted through the Dark Energy Survey. Supernovae are the final explosive deaths of massive stars, releasing enormous amounts of energy in shaping the evolution of galaxies. In massive stars, nuclear fusion generates the energy needed to balance the inward pull of gravity. But when these stars run out of nuclear fuel, gravity wins, causing the star to collapse and trigger a violent supernova. Sometimes, supernovae also occur when two stars collide. Day 16C2NM is a rare type of supernova known as a Type II supernova, which means the star was so massive that it exploded after collapsing under its own weight. What's remarkable is that this explosion occurred about 10.5 billion years ago, and its light has been traveling to us ever since, over 3/4 of the universe's entire history. Due to the expansion of the universe, Day 16C2NM is much farther away than it would appear to the naked eye. It's also categorized as a dark supernova, meaning it emitted very little visible light, making it difficult to detect. But thanks to telescopes like Webb that can observe infrared wavelengths, scientists were able to spot this hidden cosmic explosion. The team behind this groundbreaking discovery included researchers using the Magellan Telescope and the Cerro-Tololo Inter-American Observatory. It took them over 500 nights of observation across 5 years to confirm the supernova's identity. The significance of such a distant supernova cannot be overstated. These cataclysmic explosions enrich galaxies with heavy elements like iron, gold, and platinum, essential ingredients for planets and life as we know it. The shockwaves from supernovae can trigger the formation of new stars by compressing nearby gas and dust, driving galaxy evolution. Astronomers also analyze the ultraviolet light emitted by superluminous supernovae to determine how much matter was produced and the temperatures reached during the explosion. Day 16C2NM provides invaluable clues to the life cycles of early stars and the conditions of the ancient universe. You might be wondering how this compares to well-known stars like Betelgeuse. While Betelgeuse is a red supergiant expected to eventually become a Type II supernova, it is still in its pre-explosion phase. When it does explode, it's likely to become a Type IIp supernova, which is less energetic compared to the dark supernova observed with Day 16C2NM. In summary, discoveries like Abell 2744 Y1 and Day 16C2NM not only challenge our understanding of the universe's early days but also remind us of how interconnected we are with the cosmos. Heavy elements forged in these distant supernovae eventually find their way into stars, planets, and even us. With every deep space discovery, we inch closer to answering that age-old question: what lies beyond the edge of the universe? We'd love to hear your thoughts. What do you think is out there, hidden beyond our cosmic horizon? Let us know in the comments. And as always, don't forget to like, subscribe, and hit the notification bell so you don't miss the next journey into the unknown. Thank you so much for watching, and see you soon.